So we are going to solve today's daily question, that is validated binary tree nodes. And let me just copy this up to into the solve. All right. So we need to solve this validated binary tree nodes. You have n binary tree nodes, number 0 to n minus 1. So like in tree, this is the fourth node, third node. Suppose so there are like 1, 2, 3, 4, and this one is 0. So 0 to n minus 1, where node I has two children. Node I, suppose this says node I. Suppose this is node I, and it has two children. This is empty. This is null. And left child and right child, left of I and right of I. Return true if and only if. Return true if all the given nodes form exactly one valid binary tree. All nodes valid one binary tree. Of course, this is a binary tree. So, yeah, we need to return true or false on the basis of that. Uh, if node I has no left children, left child I will be equal to minus 1. Similar for right child. Note that the nodes have no values that we used, the node numbers in this problem. So let's take a look at the question again. So this is 4 and this is our input and the output. So as I said, it's going to be true. Yeah, it is indeed true. So how are we going to solve this? First, we know the fact that there are two rules. Two rules. How am I going to remove this control shift V? How I'm going to remove this? Uh, yeah, it's gone now. So yeah, like there are two rules. A binary tree has no cycle, no cycle, because like binary tree is not connected. Like in a cycle, it can't happen this way. Each node has two children, like a family tree. Similar is a binary tree. So the descendants cannot get to ancestors directly. That doesn't work that way. So yeah, this is so the root. Another factor is this root has no incoming edge. There's nothing like incoming edge. So we need to find out what is the root. Like what is the root among this? We are given left child array and right child array. How we can find out root? So the first part is we'll find root by taking set of. Okay, so we'll take a set of one these two elements, these two arrays, 1 3 2, 1 3 and 2. And what we are going to do, we are going to iterate from 0 to n minus 1, that is 0 to n minus 1, and we'll check if I not in set the combination of two. This remember, the set will have all the values from left child as well as right child. If this is not an edge, then we'll return it as root. And if there is nothing sort of that, so we'll return minus 1, that we don't have root in this, and like this means that it's not a valid binary tree. So if this is not, this is the first part, and the second part of the question says that how we can find validated binary tree. We'll apply DFS. Similarly, we can code from up to top to bottom, and for that we'll be using a stack. Cool. So first we'll be having 0 in this, and we'll be having a scene set. Scene will be having like whatever is already seen, and we'll pop this and add to scene. Okay, so 0 is seen, and we'll add now. What we are going to do? Uh, we are going to enter the childrens of this like array, whatever like both were left and right child. We're going to add the left and right child of 0. So left of whatever is removed, and it was 0. Actually, left of 0, left of 0 what? 1. So we're going to add 1 now. Right of 0 is 2, so we're going to add 2 now. Great. Now we go go ahead and we move on solving. So after that, what am I going to do now? We are going to add the uh, left of the removed one and the right of the removed one. So this was already added. Now, okay, now we are added, we are good. Now we're going to pop this and it's going to be added to scene. Great. 2. And what are the elements of whereas like the descendants of 2, 3 and minus 1. Look, we'll ignore minus 1. Minus 1 needs to be ignored. Like we don't require it at all. So it's 3, and now we are going to add the element, like we are going to add whatever are the descendants of 2 into a stack. Okay, so descendants are this 3 is there and it's already added. Now we're going to pop 3 and it's going to be added into here, and there are no descendants of 3. Okay, cool. Then we can move ahead. It's not minus 1, it's not present in scene. Remember, if it is already present, if we've popped something and it's present, then immediately we're going to return false. If we're going to break out and return false, but as of now that's not the case. We're going to return this and add into here. Now this is going to be popped, and yeah, like this is going to, I should have added it here because 0 was already popped, but never mind. Okay, so yeah, like that's what I was trying to say. This is going to be removed and this is going to be added here, and at the end I'll just minimize all, like make all of this very short, or I guess you are able to understand. So I'm going to remove the question part. At the end, what we are going to return, we're going to return uh, length of scene equals to n. If this is the case, if this is the case, then uh, we can surely say that it is true. Like length of scene means that we've seen n number of nodes, and so this is like it's saying that this is indeed true. But if not the case, which means that there are some there are nodes that do not make it a valid binary tree. This is how it's going to be done using stack. And similar is going to be the process for queue using BFS, but instead of appending, we'll just append. Uh, we're going to pop from the start and append at the end. That's going to be difference. Let's just return and solve this here. Okay. Okay, we're going to get a root equals to find root, and we'll pass left child, right child, and this is going to be a function that's going to find out find root and n a b, and now we're going to define a set s equals to set of a and okay, so for I in s, if I for I in range n, for I in range n, and if I not in s, then we're going to return I. Remember, like it is a root. It's going to be seen like it is the root. It is child of none. It is unique. That is no incoming edge. So it is the root. So okay, but if that's not the case, we'll return -1. And down here, if root equals to -1, you're going to return false. If that's not the case, and even like if okay, Okay, yeah, we can move ahead. While and we're going to define a stack here, stack comma scene, and stack will have root in it, and this is going to be set. So while stack is not empty, now comes the DFS part. I'll just write it out, comment it out as DFS part. Okay, and this top is going to be stack.top, and if top equals to -1, then we just continue, we'll ignore it. But and the other part is if top in scene, then also going to return false, that we've already encountered it, and it is like connected with another yeah, it is connected with another edge, so it is forming cycle. So yeah, that is also going to be avoided, not avoided but written false. And if that's not the case, then scene will add top, and at stack we are going to add two of the elements. What are those two? Left child of top, right child of top. Yeah, so these two are going to be added, and we're going to return length of scene equals to n, and submit it. Let's see, accept it. Yeah, so like that was it.